Problem 19. Consider this function. I already wrote it out ahead of time. K is an unspecified constant. Note that there is no, that g of negative 4 is undefined. We have x is less than negative 4, x is bigger than negative 4. There's nothing here for x is exactly equal to negative 4. So the first part here says, does the limit as x goes to negative 4 of g of x exist? So the first thing to note here is that just because g of negative 4 does not exist, this is undefined, does not mean that this limit does not exist. So if you take a look at choice D here, D says no, the limit as x goes to negative 4, g of x does not exist because g of negative 4 does not exist. The value of the function at the given point is, or whether or not it's defined, is completely irrelevant to whether or not a limit exists. So if I were to draw this picture here at this particular x value, the limit of this function as x goes to this particular x value here does exist. It does exist, even though the function is undefined there. So the real reason, so we can rule out D instantly. Let's go ahead and figure out what it is. The more accurate, kind of answer has to do with one-sided limits here. So let's compute the limit as x goes to negative 4 from the left of g of x, and then we'll compute the limit as x goes to negative 4 from the right of g of x. So as x goes to negative 4 from the left, we're in this part of the definition here. Limit x goes to negative 4 from the left of x e to the x plus 4 minus 7 natural log of x plus 5. And so I wrote the limit here, but I think this is one that we can just evaluate by substitution. So we substitute in x is negative 4. We get negative 4 e to the negative 4 plus 4 minus 7 times natural log of negative 4 plus 5. And this is negative 4 times e to the 0. E to the 0 is 1. And this is log of 1. Log of 1 is 0. So the limit from the left as x goes to negative 4 of g of x is negative 4. So now we need to compute the limit as x goes to negative 4 from the right of g of x. And we're using the definition here, limit as x goes to negative 4 from the right of negative 4 cosine of pi x. Again, this is one we can evaluate simply by substituting in negative 4 cosine of negative 4 pi. And cosine of negative 4 pi is equal to the cosine of 0. Cosine 0 is 1. So this is also negative 4. This is also negative 4 here. And so, yes, this limit does exist, and it's equal to negative 4. Because the one-sided limits are equal to each other. So that's part A of this question. Part B now says calculate the limits as x goes to 5 from the left and the right. Okay, we can do this. Limit as x goes to 5 from the left of g of x. We're going to use this part of the definition here. And so that's going to be limit as x goes to 5 from the left of negative 4 cosine of pi x. And what do we end up with? We can evaluate this by substituting in x is 5, negative 4 cosine of 5 pi, Cosine of 5 pi is equal to negative 1. So this is 4. Meanwhile, the limit as x goes to 5 from the right of g of x, we're using the other part of the definition here. Limit as x goes to 5 from the right of square root x squared minus 5 plus k. And so when we plug in x is equal to 5 in here, we get square root of 2 times 5 minus 5, 10 minus 5 plus k. So that is square root of 5 plus k. So then part C is it possible to choose a value as k so that the limit as x goes to 5 of g of x exists? Yes. In order for the limit as x goes to 5 of g of x to exist, we need these two one-sided limits to equal each other. We need 4 to equal square root of 5 plus k. So k is equal to 4 minus the square root of 5. Note that 10, g of 5 is equal to 10. The fact that g of 5 is equal to 10 has no bearing whatsoever. It has no bearing whatsoever on what the limit of the function is at that point.